In this video, we'll look at graphs and tables of quadratic functions in order to explore the properties of these functions. We'll be using the Desmos graphing calculator. A quadratic function can be written as an equation, or it can also be shown in a table. In this video, we'll be exploring quadratic functions of the form f of x equals ax squared. Let's use the Desmos graphing calculator to do this. Start by creating a Desmos window. You may want to log in. Input the function f of x equals x squared as shown. F of x equals x squared. This is the graph of a parabola with a vertex at the origin. You can also create a table of values for this quadratic function. Click on the plus sign and look for the table icon and click on it. Follow these steps. Click on plus and then click on table. By default, you'll see x1 and y1, but we want to link this table to the function we just created. Replace x1 and y1 with x and f of x as shown here. This becomes x, and this becomes f of x. Now input values for x in the table starting from 0 to 3 in equal increments, like this. 0, 1, 2, 3. You'll see that the program automatically calculates the values for f of x, along with the graph of these points. Notice how these points are not equally spaced. While x increases by 1, y increases by 1, by 3, by 5, etc. And you can see on the parabola that the points are not equally spaced. This is one of the properties of nonlinear functions. As x increases in value, f of x increases at a faster rate. Now let's add a coefficient to the square term to see what happens. Input the function g of x equals a times f of x. G of x equals a times f of x. You'll be asked if you want to create a slider for a. You do. Click on the blue button. By default, the value of a is 1, so the graph of g of x overlaps the graph of f of x. Before changing the value of a, go to the table and add the output values for g of x. So come to the table, click here, and input g of x. Now increase the value of a to 2. Now you can see the two graphs. What do you notice? In the table, you see that the values of g of x are double those of f of x. Do you see that? In the graph, you can see that g of x is a narrower parabola whose corresponding points are higher. In other words, a higher value for the coefficient a results in a higher rate of increase. You can see the increase in the table of values or in the graph. Now change the value of a so that it is 1/2. So move the slider to 0.5. You'll see that the graph of g of x becomes wider. But what does this mean? Look at the table. You'll see that the output values are decreased by half. When a is equal to 0.5, the rate of increase for g of x is less than that of f of x. Now change the value of a to a negative value. For example, -1. As you can see, a negative value for a changes the orientation of the graph. Look at the table of values, and you can see that as x increases in value, g of x decreases in value. So a negative value of a changes an increasing quadratic function to a decreasing quadratic function. In general, the coefficient of the squared term in a quadratic function affects the rate of increase and whether the function is increasing or decreasing.